So let's start. And I must say that I'm delighted because it's my very first keynote. And when I was asked to give this keynote presentation, I was a bit shocked because I started presenting as Android developer last year here in Kraków during the first droidcon, and then Gaja asked me to give this keynote presentation. And I thought that I'm not an awesome speaker, and I'm very inexperienced, I would say. And then this keynote, so I accepted the challenge. Can you hear me still? Yeah, okay. And so I thought, what's the best topic for a keynote? So why not a random guy from the internet tell you about next 10 years of Android? So maybe about Xamarin. Who is interested in Xamarin? But I tried. So let's talk about Binder. So Binder is a guy in Android that we use every day as Android developers, but very often we don't know about that because we don't care, or we didn't think that there is something more than intents, services, activities, and whatnot. So my presentation is about Binder, and I hope that after this presentation you will understand why the AIDL is not that scary thing, to be honest, and why whole Binder and the way Android works is basically just like act of nature, awesome machine. So let's start with a context, because Android is all about context. And in case of Android, Binder, I want to show you people who created this awesome framework. So let's start with this lady, Diane. She's first start with her surname, right? She's hack-born, and she's a true hacker. She was born to do that, and she's almost sole author of Binder. A few words about her. So she's using Google+. Basically, it means that she's awesome Android developer. Only Android developers are on Google+, right? So what else? 2 years at B Incorporated, old school company, like from middle 90s. They were working on operating system, also on hardware, just like Apple. And I will show you how it looked like back in the day. 4 years at Palm Source. Before that, it was Palm Incorporated. The company was changing its name because of legal problems, but it was the company who created modern handheld devices, right? Now, 10 years at Google, so basically means whole life at Google. And of course, she's on Android framework team. Basically, it's a team that created the whole activities, intents, everything that we use on our daily basis as Android developers. So that's her, and a quote about her. A quote was given by Tim Bray, a guy who created or took part in creating XML specifications. So very wise guy, worked for SGI, DEC, I guess Cray. So awesome hacker. And he said that Diane sits in the very near center of Android. So for me, it sounds like she's really the key person behind Android and also behind Binder. And of course, this quote is from this article, so I expect that she also took part in creating fragments in API. You may like it or not, but that's her child. What else about her? So basically, we all know that hackers don't have HTML skills, so this is a website of OpenBSD project. It's like this forever. Another awesome hacker, DJ Brainstein, that's his website. So guy who created Qmail and then Demon Tools. Back in the day, it was awesome software. That's his website, and that's Diane's website. So for me, it's a final proof that she's awesome hacker. And of course, she likes cat. That's her cat, Violet. And as you may maybe see here, the cat is playing with her very first LCD monitor. So I think that we all now know that Binder was created by awesome hacker. Also this guy. Looks like a priest, but George was also part of the team. He now is a software revolutionary at Yahoo. Previously worked with Groupon, of course, also Palm Source Incorporated and B Incorporated. There are other authors. I will put the slides online so you can click on the link and see there are like five people. There were 5 people on the team. So now, as we understand who created Binder, let's see. What was this created for? So Binder was created to run this hardware, this computer. It's from middle 90s B-Box. This computer was running this awesome operating system. To be honest, it looks quite nice. We have like here there are like settings, some files. So Binder was meant to run this thing, and it ended up on Palmos. And from Palmos, it moved to Android. So modern Android, those awesome, expensive sometimes devices, they have roots like in those old school times in this operating system, and in this awesome piece of hardware. So that was context. Now just like one more thing about like where is Binder situated in relation between Linux and Android. So we know that Android is a Linux, but it's not only like pure Linux. There are some extra things. They call them Androidisms, such as we have low memory killer. As you may know on Linux, if you run out of memory, Linux just like starts killing application. It's not wise to kill random application on Android. So there is this extra bit on Android low memory killer. That's first start with a hint. Please free up memory, then I will kill you. Wake locks. What else? This thing, it's a shared memory, but it's tuned for Android, so basically a bit different than regular one. There are also alarms, so our phone is sleeping, processor is idle, but the alarm will wake up our application or service. Paranoid network, cool name, but basically it's all about giving access to network to particular users. I'm not sure if it's still we are still using that in Marshmallow because there were some changes to internet permission. I think it's like internet is like for every application now with Marshmallow. And of course there is this binder. So binder is something extra on top of Linux that is only Android specific with asterisk. I will explain that later. So binder, just quick IPC and security mechanism that's on top of Linux, something extra for Android. There is much more different things in Android. There is a link, you will click, you will see. So what is IPC? So binder is IPC, and IPC basically two processes trying to communicate to each other. The problem is that, of course, on Linux or Unix, all processes have different memory areas and cannot access those memory areas. So that's why we need IPC. So basically, quickly through that, IPC, two processes, different address spaces, they want to communicate with each other, they cannot without IPC. So the reasons for that are mostly stability. I expect that if someone changed my memory when I'm working and I don't know about that, that's a crash. Also security, a reason I start application, let's say in my client, and I'm reading my email and other processes accessing my memory and also reading emails or passwords. So there are good reasons behind IPC. We also need a structured way, so let's say some kind of interface. All this, I will just like go quickly through that because there are more interesting things. Basically, IPC, so binder, is about discovery and interaction. I want to discover what other services on this device I talk to, let's say, location service. And then interaction. What are the commands? What is the protocol of communication between me and this location service or SIM card service or address book service? So IPC, discovery and interaction. Roots of IPC are of course in Linux because or Unix because that's Android. There are some kinds of IPC that we can use nowadays on Android, like files. But with files, you need a path to file and write permission. Not easy thing. With signals, basically just ping someone with signal number, and then there is no way to put a payload to that. So not very useful on Android. Sockets. Nobody like programming sockets, right? Either Unix domain or TCP. Cumbersome APIs. So we have pipes. I will just like skip that. Semaphores, no idea, never used that. Shared memory, quite useful and supposed to be fast. So those old school Unix IPC methods, they don't apply to Android because of they are like file based and there is no easy way to access files between different processes. Or sockets, cumbersome API. So guys from Google or before Google, so the Diane from BIOS and Palm Source, she invented a new thing. She invented binder, of course, for BIOS, then for Palmos, and at the end it ended up in Android. So what's binder? So very basic things. Binder, first of all, history. So it was created a long time ago as an open binder. So it's not Google thing. Then guys from Google re-implemented that to suit Android. We know it's distributed architecture like every IPC. So we have a client, we have a server, and we have some protocol of communication. Just like I think it's on Windows, it's COM. On Unix, we have Corba. And so binder is similar thing here. So it's about passing message. And by message, I mean like do something for me or take this information and have it. And of course, yeah, that's what's important about binder is that binder doesn't work between devices. So with COM or CORB or the socket-based IPC, I can call a method, remote procedural call on different server, right, on different machine. So in case of binder, it's local, but it's perfectly suited for Android. It's our own device. I don't want to send something or call a method on a different device. So that's a bit different with binder, yeah, like I said, and that's quite interesting. Binder now, the modern one is since like February this year also a part of Linux. So it was meant for old school operating system, then ended up in Android, but at the end, it's also part of Linux. So it's a quite generic tool, also useful for others, not only for Android. So that's super boring slide. Sorry for that, but I have to do this. So binder, basically there are two binders, like everything in English. So there's the binder, and the binder is the whole framework, everything. And a binder is basically an object that implements particular interface, because in binder we have interfaces. Interface is almost like Java interface. So basically it's a contract between two parties. I will support those methods. I need those parameters. If you ask me to save something, the something has to be, let's say, product. And if you ask me to get a list of something, the list will be a list of products. So that's interface. Similar interfaces in case of binder. So like I said, we have binder. A binder is an implementation of a interface, binder service and client, because like every IPC, there is a client part and service part. So someone asks somebody to do something. So that's also in the binder architecture. Binder protocol, that's low-level Linux stuff. Not very interesting, to be honest, but I will show that anyway. So that's binder protocol. Binder token, that's super interesting thing, and the whole security or identity framework of Android is based on that. So basically inside this a binder, so binder object, there is a unique integer, 32 bytes, and it's unique for the whole binder framework for all processes that are using this framework. So if I pass you a binder, then I know that only you have access to that binder. The number in the binder is like 14. And we know that I pass you number 14, so you are my friend. That's the token. Sorry for that. And last thing, binder context manager. Binder context manager is a guy who knows everything about who is on the binder framework. Basically, it's a yellow pages book. So the binder context manager, if I ask him where is location service, he will tell me where is location service. So it's so it's a directory of all services. Oh, and there's a binder driver. It's the kernel device inside of Linux. /dev/binder, I think. That was cool, but now let's find where is the binder within our Android device. So let's go through Android architecture. We have Linux kernel, so basically Wi-Fi drivers and other drivers, right? On top of that, there are libraries and Dalvik. Libraries, I mean SQL library, libc, SSL library, those Unix libraries, right? On top of that, Android framework, so lots of kind of managers. And on top of that, there is our application or Facebook application or Chrome application. So the question is, where is binder here? Any ideas? So binder is in Linux. Driver here, it's inside of kernel. Also binder is in libraries. There is a lib binder SO library, so that application can use the library to access the driver. And of course, binder is in framework, because if you want to access window manager, you use binder to get a token, and binder to access the interface exported by window manager. Also security framework based on binder. And at the end, binder is in in an application, because we can use that in our own application. So binder is everywhere, and because of that, like with everything that has a power, there comes a great responsibility. So you may remember the issue with Android design library and the fab button. On some devices, it was not rounded but square, right? So with binder, if you think that it's everywhere in Android, it's kernel everywhere. So any bug in binder, it leads to an unstable, unsecure, and not working operating system. And to be honest, Diane and her team, they created awesome framework. I guess that there were some bugs there, but it turned out that it works quite well. So great power, but they get it quite okay. So as remembered, IPC is about discovery and communication. Discovery part is quite interesting. So binder context manager, yellow book, it's service manager. It's a part of Android. it's basically this binary on your device. Funny thing, like I said, it's information directory. Funny thing that it started at the very beginning of booting of Android system. The reason for that, it's the title of being binder context manager is served on basis who's first. So Android tried to start their service manager so that it registers as the first application as context manager. If something goes not okay in this part, so I would imagine that your own application could register as a service manager for the whole binder framework. So, but luckily for us, it started at the very beginning of the boot process. That's why it's binder context manager. And what you can do, you can like go and ask about system services. So I can ask system manager, tell me what are system services, or basically what are binder services installed on the device. As of KitKat, there are 79 services. In Genymotion, a bit more, I will show you that. They implement everything what's on Android. So if you wanted to do something with display or touch, so window manager, that's binder registered service, registered with system service with service manager. Telephony manager, also registered there as system service. Download manager, system service as well. Job scheduler, everybody's favorite job scheduler, also system service. And the system service registered itself with system manager and exposed this interface for us. Very, very easy stuff. Like I said, I will just skip this boring part. And this is how you can check how many services do you have on your device. Basically, you use ADB shell, connect to your device, services list command, and you see list of all services. As you may see, there is a SIP service. So there is a here job scheduler service, search service, location service. I could imagine that you could create your own service and register it with also with a system manager, so that other application could find it there. Like I said, 79 services with KitKat, but it doesn't matter. You just use the command and see how many are on your particular device. I guess more on Samsung devices as always. On Genymotion 94 services. There were some Geny something services as well in the list. So now that was discovery. So if I want to use binder, I just ask the service manager, get the information, where is my binder service. I become binder client, I do the connection, get the information. So how works the interaction part, which is super low level, it's boring, to be honest, I like it, but just for you, I created my very first animated slide. You will see that it's quite cool. So let's imagine we have nothing, and then suddenly we have a process A. And this process A, it's a client application. It's application, let's say Facebook application, a client. And we have process B, different process space, different memory region, so there is no way to access by themselves. And the process B, let's say, is so let's say process A is my own application, process B is a Facebook, I want to log in using Facebook or whatever. So there is no, is there a way to connect in that direction? So you have listened to the first part, so there is no way, right? Because we need IPC for that, there is no way to directly access that, so we need someone to like, we need someone who has access to both processes and do the whole communication for us. And of course, best candidate here is kernel. Let's start with kernel. Kernel first. So kernel on Unix can do many things, and if we add a binder to that kernel, we have the binder driver part. So we have the most important thing that can access both process A and process B, client and server, and do the communication. So I can imagine that now in such setup, process A can communicate with kernel. Why not? And I can imagine that process B can also do the same thing, right? That's basically something everyone would expect from Unix system. But what else is needed? Basically, we need some kind of protocol of communication. Now, if you want to talk to kernel on Unix machine, Linux, you need a IOCTL. So I can just ask kernel to do something for me. So just why not use IOCTL? And if we use IOCTL, that basically is basic Linux stuff, or even Unix. So we have this IOCTL, but also we need a structure. So I can imagine it can be structured to write something using IOCTL command write, or read something. In case of binder, they created one structure for that. It's called binder write read. There is a buffer for data that to be read and to be written. Of course, other part does the same thing, right? The other process, the server process, also uses IOCTL and the same structure to get data from binder. Quite obvious thing, right? What we are missing here is, of course, two green dots. Because now let's imagine that those green dots are basically memory region that is managed by Linux or binder, Linux kernel, right? Or binder that is part of both application. But this is not regular memory region. That's memory region has two funny things. So application can read data from that memory region, so get information, but cannot write it. So if application cannot write data to that memory region, there is no binder can be assured that application won't change data, right? So once binder puts something there, application will read the information but won't change it. So that's important for the stability reasons, so that there are no naughty applications that are changing something behind binder bugs. So we have those green things which are basically memory region that are part of application, and application can read from that but cannot write from that. So how to put something from process A to process B using binder and having those green circles. How it works? Very easily. So we have some data, blue square here, and process A uses IOCTL to write the blue data to kernel. Kernel moves that along to the other side and puts that into this region that it manages in the other application. Kernel can write that data there, application cannot, but application can read data. Very easy, right? So application get information from the binder framework. Hey, there is information for you. The information came from the other side. So basically, this is a way of passing message, like making a call or sending some data to other process. So process B, let's say server, takes the data, so reads a command that has to execute, and prepares an answer. So how the answer gets to the other side? Very easily, the same thing. So basically, server process B, use IOCTL to put the data to the kernel. Kernel moves that along to the other side and writes it to this memory region that it's managed in the first process, and it's done. That's the big picture how binder driver works. We can go into detail, but it's super boring. I mean, it's super interesting, but it's super complicated. So at the end, it's super boring. But there's like everything in there. We have two processes, client, server, passing data through the kernel. Of course, you can see that there is IOCTL here and some random C structures, and we don't use that on our daily basis. So the question is, before the question, just like quickly through the features. So we know that there is one or two-way communication here, like the blue box went to one direction and the response get back. We can just like send data, get it back. That's a feature of binder. Binder can manage many things, can manage threads. So if you make a call, so when the blue box went from the left side to the right, the process A was paused by binder to pass the data to server and get back the answer. Because binder managed threads can pause our application during, like, say, two-way communication. When I send a message and want to get answer asynchronously. Synchronously. Manage memory. The green circle is memory that binder is managing in different application. Binder can do that because it's a part of kernel. Object mapping. So I showed you that there is the blue box went from one application to the other, but the truth is that it's kept in the kernel. So there is it's optimized so that there is no much of memory copying between userland and kernel. Reference counting. That's quite interesting thing, but of course, binder is keeping track who has something and how many applications are using how many objects. So in case an application dies, binder can free up space because it sees that this binder object is not being used anymore. Also, there is a way, thanks to that reference counting, binder can notify us. So it's got, I think, a link to dev. So if I'm a client and I start a server and the server dies, I can get information from a binder that the server just died. So it's not obvious that there's a client and server application on Android, and we just like have sometimes to restart the server because it died because of memory pressure or whatever. So with binder, if we go with binder, we can like keep track if the server is running and restart it as soon as system kills the server or there is a bug in the server. So that's the notification. Okay, of course, identification. Remember the 14 number right between us. So it's a part of binder, so I can identify you because I gave you the binder with number 14, right? And identification as its kernel, so it's basically also process ID, user ID, and this funny token. Other features, marshalling thing, binder has to move stuff around, just like obvious stuff, right? So you can marshal data from like float from one application, move it to other application. We call it parcels. We use that on daily basis with intents. Yeah. And security thing is basically based on identification. If I know who are you, then I can like build a security framework on top of that, right? So the same thing, security, basically identification, the same stuff. So yeah, of course, funny thing about sharing file descriptor, nobody use that, but binder, if you are low level, you can use binder for that. And local execution mode, that's actually quite interesting. So you saw that there were two process A and B client server, and I pass data from one side to another side, right? But imagine that those processes are part of one application. So binder sees that I try to communicate with my own service, and in that case, it doesn't have to go through the kernel, so it just directly connects me to the service using a local, I guess, shared memory within my application. So binder is quite smart and optimized for that as well. So binder features, a few of them, I guess there are many more. But now, as we understand how it works in the kernel world, let's move to Java, and I will show you binder in action. And basically, it's a game. I will show you a bunch of Java, and you tell me where is binder here. Intent, basically intent, it's a part of binder, but it's just a parser, but it's a bunch of data like strings and bundles, so it's not binder. Start activity. So context uses binder to start activity. I need context, and starting activity underneath there is a binder. Use it every day. So we need intent, basically some data like string, that's action, and some extra parameters like extras or bundle attached to the intent, but that's not binder itself. Then we need context because it's everywhere on Android. But when I start activity, I use binder to start the activity. And to be honest, I wanted to show you that. But before we go to the, let's say a few words about intent. So we know it's, first of all, we use it every day, but what we have to know, it's a high-level API on top of binder. It was, the idea behind this to be very easy to use for us. So basically just action and bunch of parameters instead of doing all these IOCTLs, right? So it's easy to use, but of course a bit limited. So limited types, only one action in that case. Of course, if you see that there is the string action, I can like, the API is it's not well defined, but in that regard, I can come up with random actions and I hope that server will understand the action string that is passed along with the intent. So it's easy to use also without the strong type like interface. It's easy to mess with that, so it's prone to runtime errors. Like I said, intent is just bunch of data. And but what's fun about intents, just like you know that I just pass intent and get it back, that easy stuff. But I wanted to show you how the intent works underneath. So I just like started reading code, and it basically intent, it's implemented in those 4 files, I guess more than those 4 files, but I was like done after the 4th one. So I just like opened the Android sources, went with Activity Manager Native, it's like 6,000 lines of code, quite interesting lecture to be honest. Wanted to find you something for you there, but yeah, not too much time. Then I went to the Activity Manager, 600 lines of code. And like I said, I was done when I was reading this Activity Manager service. It's like 20,000 lines of Java code in there. But all of this is binder stuff, and every time you just like start activity or start service, it goes into that Activity Manager Native, Activity Manager service. There are lots of binders there. The Activity Manager service is being asked by system where the hell is the activity that is using supporting this action and this activity. So no code here in this case because lots of code, but you can trust me that the binder is there, and of course, as you can see, it's iActivity Manager. That's another proof that's binder there. Every binder comes with interface. All interfaces start with I in case of binder. But I have something that is much easier to show. Where is binder here? Yeah, it's stub service, but that would be too easy, right? So let's do it properly. So let's imagine that there is this messenger thing. So I want to start a service and get back data from service. One of the ways of doing that is basically pass a messenger along the intent. So I start service, pass the messenger, and the service using messenger to pass data back to my activity or process, right? That's how Android framework works more or less. So the binder here is in the messenger thing. Let me show you that. So we have 2 applications, A and B. One is activity, another is service. Activity has very often has handler that has a callback to the activity. That's quite normal thing, right? We post runables on the handler, and normal stuff. You do it every day. But we can also create a messenger on top of that handler. And what happens here, if I have an intent, I want to start a service, I just like start service and pass the intent to the other side, right? But also, I can, like as maybe seen, I can attach a messenger. So basically what happens here, the messenger is passed to the other side, to the other process, to other application, and now the messenger is here and there. And we can use messenger to pass data. So service can have access to the messenger, and then suddenly there's a blue dot, which is basically a message. And the message can go through the messenger and handler back to the activity. So, for instance, service can say, I have a data for you, pass it along the messenger, then handler, and the handler, if it gets a data from the internet, can show that in the activity. And what happens here is that the messenger guy, the guy in the middle shared between activity and the service, he's a part of binder framework, yet another high-level API. So messenger on top of handler, messenger that can use messages to pass data. Intent is a string and a bunch of data. With messenger we have int called what, int called arg1, int called arg2, and object. Very useful API. But yeah, we can use that, and then messenger is asynchronous API, so it's but it's faster than intent. So if you start a service and wait to service to get you back data, let's say using a broadcast receiver, it's faster to go with messenger. And now where is the proof that messenger is using binder? So the first proof is here, but if you don't trust me, you can look at the source. So messenger implements parcelable, so that's the parcel thing that binder is using to pass data through the kernel. Another thing, of course, the inside of messenger we have iMessenger, that's binder interface, the interface defined by binder. And of course, in the middle of that, there is this get binder. That's the final proof that messenger that we very often use is using binder under the hood. So where is binder here? So basically, that's interface, but that's not Java. As you can see, that this is in-out thing in here. So that's not the Java. That's this AIDL thing. And to be honest, for me, it was like a super boring and creepy thing from Google, AIDL. I'm supposed to create such Java-alike interface and then use this AIDL converter to convert that into this. And for me, it was like, what the hell? Why so many steps and why it's so cumbersome? And the reason for that is there's a very good reason behind that. And also, I think that this final example shows the whole power of binder, and also the quite nice thing on site of Google that they provided us with this useful tool. So first of all, we want to create a random interface between two parts, like client and server. So we write this very simple interface file, almost like Java, like add method and get products. Use the AIDL command to convert that into this. So why it's binder, of course, we can see that it implements binder, lots of binder-alike things inside, like I interface. So basically, this AIDL is using binder to connect two parts and create an API for that. What's funny thing about this, I would just like skip, so like one more information that will show you the whole picture. So AIDL, this programming, so to speak, language to define interfaces. It's using binder under the hood, and all binder services are defined using that, I mean system-wide, like window manager and location manager. That's all using AIDL. And what funny thing with let's say with intents or messenger, very simple types are supported. And if we go with AIDL, we can use all the power of binder. So we can pass null, floats, arrays, list, iBinder, and then even file descriptor if we care. There is a problem with passing back exceptions. So if I have a service, I cannot run or throw a random exception. I just have to throw like 4 kinds of exception. Luckily for us, there is null pointer exception included. Yeah. So why the hell we need this AIDL, and why the AIDL is awesome thing? So you remember this? So that's the big picture of binder framework, client and server. In this case, there was a process AB. Here is a client and server. But as you may remember, on top of kernel, there is this IOCTL, this binder protocol. It's low-level stuff. And we Java developers don't like that. We prefer something a higher level. So what AIDL does, it gives us a proxy and a stub. That's created by AIDL. Proxy is meant for the client, stub is meant for the server. Let me show you that. Once again, not the animation, but here. So that was the interface I have to create to use AIDL. And then this is called generated by AIDL tool. As you may see on the top, there is this stub thing. And on the bottom, in the middle, there is this proxy thing. So that's what AIDL is creating for us. In the comments inside, you see there is onTransact and iBinder remote. I added this just to show you that the onTransact thing, it's this low-level binder stuff that stub and proxy is like putting a nice API for us on top of that. So we could write that ourselves, like low-level binder stuff, or thanks to the AIDL, we can get for free stub and proxy, higher-level API to access binder interface. Yeah. So we have client-server, we have proxy and stub created by AIDL, and then we, as a developers, we just like interact with the proxy. And the communication between client and proxy is high-level Java. I can call add method, pass a POJO object client or product, and under the hood, the proxy will convert that to the low-level parcel stuff and use the binder low-level calls to pass that along the kernel to the other side. On the other side, server gets a kick from stub, hey, wake up, there is a data for you. So the server gets the data basically by a callback of high-level Java function like on data received with product already unmarshaled, unpacked, with good and easy to use a POJO object. So that's I think the third thing that we not always know that it's also binder based. And the last but not least, this is a for question part, but I wanted to show you that's binder manifesto. It's from The Onion. It's super funny, right? So they went to The Onion like in 1997, something like that, found a random article of this guy. He's called Smooth B. You can Google him. So basically it's a guy, he's columnist in The Onion. So basically random crap written every week. So they took one of his essays about, I think, women in this case, and converted women to system service, and that's their manifesto. So before they created binder, the binder was created based on an article on The Onion. So thanks a lot, and sorry that I'm very sorry that you weren't interested in Xamarin. Maybe next time.